Welcome to Do Attribute Structures String, part of the InfiniteGraph video series. In this video, we will discuss the InfiniteGraph string attribute data type. Before we begin, let's do a quick review. Remember, the general form for the update schema create class statement is shown here. Update schema, open brace, create class with a class name, in this case person, open brace, followed by an attribute structure, which consists of an attribute name, a colon, and then an attribute body. The attribute name is the name of the field. In this case, it might be first name, last name, or date of birth. The attribute body is the data type of that field. Simple data types include string, boolean, character, integer, real, GUID, and various date-time types. Complex types include references to other objects, list, set, and map. In this video, we are going to cover the string data type. Let's define a person class. This statement will update the schema, creating a new class definition named person with the specified attributes. In this case, first name, middle name, last name, and date of birth. Note that each attribute type is followed by a comma except for the last one. What is a string? A string represents a sequence of characters in text. The type characteristics of a string attribute are determined by the character encoding and the allocation of space. In InfiniteGraph, a string value is implicitly terminated by a null character. Storage for the null character is managed automatically. You do not need to count it explicitly when specifying the maximum size of a fixed capacity string. In InfiniteGraph, if you simply declare an attribute to be of type string, the encoding will automatically be set to UTF-8 and the storage will be variable. A sample declaration is shown in the quick look column. Last name, colon, string. But we have more options. The encoding can be byte, UTF-8, 16, or 32. The storage can be variable, fixed, or optimized. When you use the fixed or optimized storage, you have to set the value for fixed length. In the quick look, we see our previous declaration, last name, colon, string. Then, in the second example, we are specifying the encoding to be UTF-32 and the storage to be variable. If we hadn't specified the storage, it would have been set to variable as the default value. In the third example, we are declaring an attribute state with an encoding of byte, storage as fixed, and fixed length of 2. This makes sense if you're creating something like an address class where we can use the standard 2-letter abbreviation for states. We don't need the overhead of a variable string because we know that it will always only ever be 2 characters. I'm not going to go too deep into the various encodings except to say that you should be aware of which encoding you should use to support the text data that you need to store. If you are storing text that only uses ASCII or the ISO Latin character set, you can use the byte data type. Otherwise, you should use the UTF version which supports the text for the language or languages that you need to store in the database. A quick side note. InfiniteGraph provides complete support for both the storage of the various UTF text types as well as the querying of those fields using the same UTF text types. InfiniteGraph supports 3 different kinds of storage for strings. Variable length strings are used to store text of any length. You don't need to know anything about the size of the text that you might store. You can use a storage type of fixed if you know in advance how long your data will be for every occurrence of that object. The state example that we discussed earlier is a good example. We knew that the state field was always going to be 2 characters, so using a fixed storage and a fixed length of 2 made sense. The third option for storage is optimized. Here, the allocation for strings that are optimized for, but not limited to, a particular size. This will make more sense in just a minute. The fixed length option applies to fixed and optimized string storage. A variable string is a sequence of any number of characters. Variable storage is appropriate for an attribute that will store strings whose lengths are not known or are known to vary widely. Structurally, a variable string is a compound object consisting of a reference to an extensible vector of elements or code units. The reference occupies a fixed amount of space in the object. When a schema class has a variable string attribute, storage for the reference portion of the string is embedded in each object of the class, and storage for the vector portion is allocated outside of the object. The vector occupies a variable amount of space and may be relocated by certain operations. Elements in the vector are guaranteed to be contiguous within virtual memory. An optimized string allocates space in the object for the fixed length size of the attribute, as well as a reference. If the size is less than or equal to fixed length, the data is stored in the object and the reference is unused. If the size of the string data exceeds the size specified by the fixed length value, the space in the object is unused and the data is placed in a vector and pointed to by the reference. If the majority of the sizes for the attribute are less than fixed length, using optimized storage can result in improved performance. String attributes are used to store text data. InfiniteGraph supports a variety of encodings including byte, UTF-8, UTF-16, and UTF-32 to support the vast majority of languages. InfiniteGraph also supports a variety of storage models including variable, fixed, and optimized.